Our keynote this morning is going to be from Erik van der Bergh. He is at Wageningen University and Research. He's a senior information manager of research there, and also the chair of the Yoda Consortium, which is why he's more on our radar than otherwise. He has a PhD, and then after that, he went to Earlham Institute and worked on, among other things, the Cyverse UK project, which is probably, I think, when he first saw and heard of the iRODS. He then went to IMBL and the European Bioinformatics Institute, and then in 2018 came back to Wageningen, and I guess now with the Yoda Consortium starting 2 years ago, 1 year ago, officially. Yeah. So we are happy to have him here and say all the smart things. Welcome. And please welcome Erik van den Bergh.
Welcome, everyone. Thank you for joining us. Thank you for the organizers for inviting me and for your kind words. I'm not sure if I'm going to say smart words, but I'm going to say some words. So, and of course, everybody joining us from across the Atlantic. How are you doing? How's your jet lag? I have a 6-month-old at home, so she usually wakes us up somewhere between 5 and 5:30 in the morning. So I know how you feel. But you know, together we can make it to the next coffee break. So let's do it. Illuminating dark data. It's the title of my talk, and I will tell a little bit about how we here in the Netherlands are trying to illuminate the dark data that we have. And also I'm going to convince you why you should stop storing data. But first I'll kick off with some TV. So this is the Antiques Roadshow. I'm sure, I know that it's a British show, but I know that it's also in the Americas. In the Netherlands, we call it tussen kunst en kitsch. And the principle is very simple. People bring stuff, old stuff that they have in their homes, and they find out whether it's worth really a lot of money or just no money at all. And so actually this picture is from subreddit Antiques Roadshow Memes, which is like, wow, there's a subreddit for everything. I don't know, is there an iRODS subreddit? Someone, if not, someone create it, please. But so there's a spin-off show in Britain called Cash in the Attic. And that's basically the tagline of the show. Like, that's what people want to find out. How much do I still have in my attic? And actually, the scientific institutes that we work for, we also have a lot of cash in our attics. So this is a survey under US scientists where it's revealed that 40% of their data is never published. They have about 10 to 24 unpublished data sets. They have around 300 to 500 unused samples, representing about $29,000 worth of unused resources. And then if you add that all up across different disciplines, you can see that in the social sciences, this is about 8% of all data. But in the life sciences, which is where my university, Wageningen University, specializes in, is up to 63% of data goes unpublished, representing about $3.9 billion worth of value. And these are US numbers, but I'm quite confident that in European numbers are very similar. And of course, I think so in other countries too. So there's this iceberg, right? We have published data at the surface, and then we have a lot of unpublished data because they are negative results. They are orphan data, so data that doesn't really fit anywhere else, but is nevertheless logged. Ancillary findings, so things that are interesting, but just don't fit the narrative of the paper that the group is currently writing. And of course, a lot of unfinished projects and unused samples. And in this paper, the authors actually suggest that addressing logistical problems can increase the efficiency of research. And that's what I want to talk about today and what we're trying to do with the Yoda Consortium. So first, let's define it a little bit. So what is dark data? We know that researchers need to ensure that their data and metadata comply with the existing standards to be useful. And you could even say it more strongly, saying incompatible data is essentially useless for further research. And however, researchers have to allocate time to standardize their data and learn and keep up to date with the current standards of repositories. However, our institutions do not really support or incentivize that work. So it becomes ancillary work. And there's very little incentives for researchers to share, format, and standardize their data. And the lack of support leads to reduced professional collaboration, wasted research efforts, leading to dark data. So valuable scientific data to become forgotten and underutilized, even though there's significant costs associated with how they were created in the first place. So this is what we refer to as dark data. So for the audience, please raise your hand if you have a role in either storing data, managing data, supporting data. Could you just raise your hand? Yeah, it's going to be most people. Well, keep it up, keep it up, keep it up. If you think that you have dark data, please keep your hand up. If you think there's no dark data in your institute, please lower your hand. Yeah, exactly. I didn't see anyone's hand going down. So we are all extremely aware of this problem, right? We know that we have a lot of cash in our attics, all of us. So not only is this a waste of scientific resources, it also takes up space, energy, time to maintain. And so if, putting it strongly, dark data could even be killing the planet. It's maybe taking a bit far. So how can we solve this? And one of the main ideas that I think we're trying to work towards, one of the main principles, is that we distribute and standardize. So the observation is that data will always be generated in a lot of different places. There's a lot of different institutes, a lot of different laboratories that all together generate data. And so we're moving data around constantly, but that means copying, creating different versions. And that's how a lot of data ends up orphaned or forgotten. And so instead of that, we want to leave data where it is, but make it accessible through interfaces, technical interfaces, APIs, so that users and applications can access them when needed. And so by doing that, we can improve the control, findability, and security of the data. So we want to stop storing data, stop putting it in your attic. We want to start managing it. And to visualize this a little bit, I have this movie, this idea of the farm data train, which I want to show, which sort of puts this into context nicely.
The farm data train's main goal is connecting agricultural data to make them more usable. Modern farm management requires ever-increasing amounts of data, but today this information cannot easily be used because the data are produced and managed by various manufacturers of machines, authorities, and more by farmers themselves. These stakeholders collect and manage their data in different ways, making the data hard to find and use. Furthermore, as some of it is public and others need to remain private, specific farm information is often very business critical. As a consequence, farm data cannot be used easily by farmers themselves, nor by agronomists and researchers. The farm data train goes to the root of this problem by building fair data stations. Fair protocols ensure that data are findable, accessible, interoperable, and reusable. These data stations are connected by tracks which are strictly secured and protected. Fair data trains are constantly monitored, and only trains with the appropriate validation may enter a particular station. To secure privacy, every data station has rules. Each data owner has access to his or her secured station and can easily request and control one's farm information. In addition, the owner can set rules for who can access the data and how it may be used. In addition to individual data stations along the track, communities with common interests like farm cooperatives can choose to connect and organize their information discreetly grouped through umbrella stations. With access to farm data, a researcher can learn, for example, which crop variety will grow best at different locations under certain crop management. Or a crop breeder who wants to breed a climate-resilient, robust variety will be automatically alerted when new research results, insights, or possible risks become available. In this approach, the information is accessible for farm management, research, and education without the data ever leaving the station. The farm data train takes farm-specific crop management to a whole new level, safeguarding full control of the farmer's own data.
Okay. Yeah, so this is an example of our domain. And I think the key sentence here is that data remains at the source. And that's the idea that we want to work towards. The other thing that you heard are the FAIR principles. I'm assuming most of you are familiar with these. It's the principles that we think that scientific data should have in order to prevent it from going dark. And so these are human principles, right? Findable, accessible, interoperable, and reusable. They're not technical guidelines, although there are a lot of attempts to actually do that. But we're still struggling with that. And so this was the big idea, right? So we have this expectation, we have the shiny movie, but then there's the burnt toast of reality. And so what we see is that in practice, this is a investigation under EU researchers. Up to a third of them have never even heard of the FAIR principles. And then another third have heard of the FAIR principles, but have no idea what to do with them in any practical sense. Also, if you look at activities that you could consider FAIR, so for example, using ORCID, so persistent identifiers for authors, looking for data, developing a data management plan, using standards, all these kinds of things. Most of these things, up to half of the scientists never even really perform these activities other than looking for data, which I guess is pretty obvious. So why? Why do we see this lack of adoption? And I think Scambera and Duran, they have this paper in 2019 about dark data as a new challenge for big data scientists, for big data science. And they describe it really well. They say researchers who want to share their data have to make sure that the data and the metadata are compatible with existing standards. Incompatible data might be as good as noise. But they have to find time in their already busy agenda, not only for standardizing the data, but also keeping up to date with the standards used by a given repository. However, our institutions do not incentivize them to do so. And as a result, data goes dark. And so we see researchers, they want to do science, but they feel that making data fair is a drag, right? It takes them time that they don't want to spend. And this is where Yoda comes in. So what is Yoda? It's a system for fair research data management. A lot of more details are coming at 3 p.m. today. Suryan is giving a talk on Yoda, so I'm not going to steal his thunder. But I'll just do a quick overview. So Yoda is based is a research data management focused graphical interface on top of iRODS. And it started off as part of the youth data project, the youth data platform, leading to the name Yoda. Of course, any similarity to popular science fiction characters is completely coincidental and should be completely ignored. The features of Yoda is that basically it makes it easy for scientists to do data management. And I think the big difference is, the key takeaway is that it's not a repository. It's not something that we expect scientists to put their data after the research is done, but it's something that they can use every day during the active part of the research cycle. So they can use it for metadata management, but also for archiving, so also as a repository, and easily sharing data inside and outside their own institute. So then, the Yoda Consortium. This is the timeline of Yoda as I could find it. I know Ton is in the room, so if it's wrong, please correct me. In 2015, Yoda development started, and then in 2017, it was published open source under GPL license in GitHub. And then in 2019, it became so popular within Utrecht University, who is the original developer, that they said this could be useful to other universities. And then other universities in the Netherlands started piloting. After about 4 years of pilots, it became so successful that these universities that came together and started a consortium to further develop and promote the use of Yoda. And so 6 out of 13 major universities in the Netherlands are in the consortium and 1 university medical center. As a side note, there's at least 3 universities that I know of that use other iRODS-based research data management solutions. And the consortium partially funds and governs feature development of the Yoda software. And it also represents the user group for the hosting of Yoda by SURF, our sponsor today. So the consortium represents right now within different institutes, there's about 15,000 users of Yoda and up to 3.5 petabytes of data. And of course, this all sounds really impressive, but then you realize that the Netherlands is about a third the size of North Carolina, right? So take it all with a grain of salt. But for us, it's really impressive. And the reason that Yoda became so popular, and that's what we've seen in our institute, we've seen since we started the pilot in our own institute, a growth of about 1,000 users per year without any significant promotion or changes in our policy. So just from the groups that started piloting with it, through word of mouth, the use of Yoda spread through the institute, is spreading throughout the institute. And I think the key feature of that is because what I said, Yoda is not a repository, but it's an active research data management solution that scientists can use. And they feel this problem. They want to make data fair, but they just don't have the time. So making it easy for them can really improve the adoption of these principles. So practical research data management tooling. So iRODS together with Yoda and SURF providing federated authentication is how we're trying to work towards this model, this farm data train of this connected network of different data stations that all exchange data with each other. And of course, there's a lot that we still need to do, such as, for example, this sort of discovery, querying and presentation of all this data that's interlinked, because right now it's still institute bound. And that's of course possible because the data is all indexable, but that's something that still needs to happen to make it a lot more visual. So there's a lot that still needs to be done, but I think establishing this core network of compatible data stations is really what we're working towards. So to recap, dark data is a significant problem in most Dutch scientific institutions. However, Yoda is a tool that supports researchers in their day-to-day data management activities, as well as enabling the verification of data. And right now, that's creating a large and active iRODS user base here in the Netherlands. And the Yoda Consortium model creates a federated data network without a single authority, right? Because the data stays at the institutions and stays the responsibility of the individual institutions. But it can still be exchanged. And we think that this could be a model to expand not only within the Netherlands, but also outside within EU projects, such as GAIA-X, European Open Science Cloud, and EU national activities. Thank you very much.
All right. Do we have any questions for Erik?
I have a question about how the fair how does a FAIR protocol handle protected and sensitive patient data, things of that nature?
Yeah, I think that's a very good question. It's a question that we often get. And I think the important distinction to make is that when data is completely fair, it can be 0% open. It can, because FAIR is just defining the accessibility, but it's not saying everyone should have access to it. It could be very well that you define in your FAIR metadata that only one single person is the administrator of the data, and that's the only person that gets to see it. So data being open versus data being fair are not mutually exclusive. In fact, FAIR is just describing how open your data is. So it can very well work also for very sensitive data. Yeah.
All right. Any other questions? All right. Thanks, Erik.
Thanks.